Welcome to the F5 application provisioning demo leveraging VCAC, NSX, and F5 big IPs. We'll start off the demo in the service catalog where we see that there is one multi-machine blueprint defined called VMworld. We will start the provisioning request of this multi-machine blueprint. As you can see, this multi-machine blueprint is comprised of multiple individual blueprints. There is a database server, an app server, a web server, and a big IP VE. We will go ahead and submit the request for the provisioning of this blueprint. The request has been submitted, and we'll take a quick look at the definition of this multi-machine blueprint. As mentioned earlier, this is comprised of 4 single machine blueprints. Please note that the web server has a minimum instance of 5, which means it will deploy 5 instances of this web server. VCAC has the ability to provision NSX VXLAN wires as part of the provisioning of the blueprint. That is done by defining network profiles. If we take a quick look, we will see that there is the application tier network is defined as 172.16.20.1 with an IP range of 20.10 to 20.100. We associate the build machines with their dynamically provisioned network by going to the machine blueprint and editing the network settings. You will see that this machine is associated with the app tier network profile and will receive a static IP address. While the machine is provisioning, let's take a look at the vSphere web client. Under Networking and Security, and then NSX Edges, we will see that a new NSX Edge is currently busy. This is being deployed through VCAC to the NSX. It is a version 5.52 Edge. The deployment of the new NSX Edge has completed. Let's take a quick look at the configuration of that. We will see that there are 3 new networks, one for web, app, and database, as well as an external network that is used for routing traffic between the web tier and the external networks. If we take a look under hosts and clusters in our vSphere web client, we will see that machines are being provisioned as part of our blueprint. As you can see, we currently have 3 of our web servers already provisioned. We now see that the big IP has finished cloning. If we refresh our screen again, we see we have our 5 web servers, we have our app server and our database server, as well as the big IP. If we take a look at one of these, we first see that the IP address is from our network profile. And the network is actually associated with a virtual wire that was dynamically created as part of the blueprint. If we go back to our vCloud Automation Center, we'll see that our request was successful. And if we go under our individual items, we will see an instance of the multi-machine blueprint has been deployed with all 8 machines. Now that the multi-machine blueprint has successfully been deployed, we will move on to the next portion of this demonstration. We're leveraging F5 BigIQ and VCO objects. We will finish the provisioning of the F5 BigIP. The F5 BigIQ is primarily used for the orchestration of F5 BigIP products. BigIQ has introduced some new functionality to the F5 product suite. One of those is pool licensing, whereby you can register a device with a BigIQ and automatically have a license issued from a license pool. If we take a quick look at our recently deployed BigIP, you will see that upon logon, we have a no license exists for this device warning message. We will leverage the VCO plugins to register this device and issue a license from this pool of licenses. Let's switch to the VCO client. F5 has developed a custom plugin that allows us to work with the F5 BigIQ, GTM, and LTM through the VCO. Let's take a quick look at our workflow. This workflow will be passed one parameter, the name of our newly deployed BigIP. From there, it will grab the management interface, update the date and time, import the certificates, and through a series of REST calls, will register and issue a license through the BigIQ. Let's go ahead and start that workflow. Although we're passing a parameter here manually, you can also leverage the VCAC workflows to pass parameters directly to the VCO workflow. As part of the initial device registration with the F5 BigIQ, one of the first things it does is update the REST framework on the BigIP. As you can see, as the device is being registered, it goes from the pending to the active state. As you can see, the device has been successfully registered with the BigIQ, and a license has been issued to that BigIP from our license pool. If we take a look back at our BigIP, you'll notice that we no longer have the license warning. Let's take a quick look at the current configuration of our BigIP. As this is a newly deployed BigIP, you will notice that there are no virtual servers, load balancing pools, or network configuration on this device. We will now leverage a separate VCO workflow to complete the configuration of this big IP. If we take a look at the configured big IP workflow, this uses a combination of REST API calls as well as our F5 VCO plugin to update and configure the big IP. As part of this workflow, we will dynamically add all 5 provisioned web servers. We do that by querying the vCenter for a list of host names, and then one by one add those to the pool on the big IP. Let's go ahead and start this workflow. So again, we will provide a set of parameters for this workflow. And as mentioned earlier, these could all be automatically provided directly from VCAC to VCO. We will now initiate the configuration of our big IP. We have now completed the configuration of our big IP. If we take a look back at our big IP, we'll see that we now have VLANs defined, self IPs, networking routes, a big IP pool with 5 members, and a virtual server. And now we see our web app successfully working. If we go back and take a look at our pools and the statistics, we'll see that only one pool member has been hit with traffic. We will run another quick test using the TinyGit application, which will simulate 20 users hitting the website 5 times each. And you can see traffic is now hitting all of our virtual servers. This concludes our demo. Thank you very much.